Hey everybody, this is Chad Tyndall. We're live here with DocumentDB from the dining table, episode 5. Thanks for joining us, and let me get my PowerPoint going here. Um, I'd like to introduce my guest co-host, Karthik. Karthik, say hi if you want to introduce yourself to everybody.
Hello, folks. Nice to meet y'all.
Yeah, Karthik is roughing it out in the wintry Dallas, Texas, surviving the snow that nobody down there is used to. And we have some other people from Dallas joining us today as well. And of course, I'm in New York and it's got a blizzard going outside. So we're just hoping that all of our internets and utilities hold up through the next hour. Hopefully, we can bring you this great show. Let's dive right in. You know, we always start the show with a quick intro to the DocumentDB service in case we have any people joining us for the first time, wondering what this whole DocumentDB thing is. And so DocumentDB is a service on AWS, a MongoDB compatible database service. And it's compatible with both the MongoDB 3.6 and from a recent release, it's also compatible with the 4.0 API. So when you use the DocumentDB service, you're going to be using the same SDKs, command line tools, GUI applications that you might have used with MongoDB. You can use those same tools to connect to DocumentDB. And we're going to see actually later in the show a demo of a few of the ways that you can use those GUI tools to connect and do work with DocumentDB. DocumentDB is a extremely fast NoSQL database capable of serving millions of requests per second with millisecond latency. Our architecture is a little different than what you might be used to with some NoSQL databases because we actually separate the compute and storage layers of the product, and you can scale those independently. So there's no requirement, for example, that just because you want to add storage to your cluster that you need to add a bunch of nodes to your cluster. Those are sort of separate. So if you want to add more storage, you scale the storage. If you want to add more nodes to be able to service, say, more requests per second, then you add more nodes. And those are sort of independent of each other. You can scale up to 15 read replicas very quickly. And you can scale up and scale down as you need to, depending on what your workload requires. It is a fully managed service where you don't need to actually provision hardware, install operating systems, deal with security patching, any of that stuff. All of that's managed for you, and backups are automated. So, it basically allows you to just spin up the database that you need and get to work right away without having to do a lot of the undifferentiated heavy lifting of provisioning servers and such. Karthik, anything that's worth adding here for anybody who doesn't know about the service?
No, I think you covered it pretty well. I just want to, make it clear that the storage scales automatically. So as your data volume grows, we increase the storage for you, so you don't have to worry about provisioning storage. Storage and the IOPS automatically scales for you.
Oh yeah, good call out. Yeah, I definitely wasn't clear about that. Thank you.
Sure.
All right. Yeah, and so if any of you are new to this, we did have, of course, reInvent a couple of months ago, or I should say over the last couple of months, and there were 5 sessions that were DocumentDB focused. Well, 4 sessions that were DocumentDB, and 1 session which is talking about all the AWS databases and the future of them with our VP Sean Bice. So the links are here. There's a really good deep dive into DocumentDB and how the service works. There's couple of good customer references. Zulily did a full-on presentation here about their use case with DocumentDB and how they use DocumentDB to implement a really cool feature that allows them to show people what products are trending, what items are trending, things like that. So if people want to discover like hot new things or just what's new out there that people are buying or focused on, that anyway, they implemented that feature using DocumentDB and Kinesis data. There's a good explanation of how to migrate to DocumentDB, and then there's this what's new in DocumentDB that our product manager Meet hosted, and the last 10 minutes or so of that is actually a nice presentation from the Washington Post on how they use DocumentDB. So a couple good customer use cases in here. People are interested in seeing what's going on with that. I think Karthik is going to post the links into the chat here. And so if you want to, feel free to click any of those links, of course. We'll put these slides up for people to download on the YouTube channel afterwards. Come find us on our YouTube channel, and you'll see links to this slide deck as well if you want. All right. All right, so I'm going to turn it over to Karthik. He's going to walk us through some new stuff that we have going on with our hands-on workshop, which is hosted. There's also a link here, and I'll post that link into the chat as well. This Immersion Day workshop, which is publicly available for anybody to use. and he's going to walk us through kind of what that is and how it works and how you can use it to try the product.
Cool. Can you hear me okay, Chad?
Yes, I can.
Let me share my screen.
Right.
Oops, not that one. Oh, this screen. Let me know when you see the screen.
Yep, it's up.
Cool. So thank you, Chad. Hey all, I just wanted to introduce you to the Amazon DocumentDB workshop. We put this together a couple months ago, and I've been delivering these to our customers. The good thing about this workshop is it's completely self-service, right? So you can use this, as time permits. And I did publish a blog a couple months ago on what this workshop is. Like, it's a very quick read, like a couple minutes. On what this workshop is. So this is the blog. I'll share the link in a bit here. But also, like, talking about the workshop itself, like Chad was showing in the screenshots, it is publicly available. You guys can access it at this link, documentdb-immersionday.workshop.aws. And the good thing about this is, there are, like, right now 4 modules, and we continue to add modules to these. Right. So, and the modules are incremental. They are completely independent of each other. So if you, let's say, for example, you're new to DocumentDB and want to get started, introduction module would be a great place to go to, right? So if you go to this module, it'll not just talk about, step-by-step instruction for the labs. It'll give you some background and, educational level information so that you can learn and understand what you're doing, and also, get that hands-on experience. So in this module, if you look at, like, we have in the setup section, I have given a cloud formation template, so you can use that to set your environment up, and then you go about installing or provisioning DocumentDB cluster, right? And then once you do that, we have sections for querying the cluster, like performing basic CRUD operations. There's a sample Python application for those of you that are learning Python or want to get started with Python and DocumentDB. This is a good place to go to. And then I also talk about how to scale your cluster. What are the various scale operations you can do, how you can do with some screenshot references here. Right, so these screenshots, they may not be exactly what you see today, because recently DocumentDB, UI was upgraded a little bit, but regardless, the concepts are still the same. So you should be able to follow through these to get through the module. And then the way we have designed other modules are, you can, if you're already familiar with DocumentDB, you can just go ahead and say, I want, let's say, for example, if you want to learn only about how to migrate from MongoDB, you can start directly at this module, and the templates, the CloudFormation templates, the way we've designed it is it's builds on top of one another, right? So if you've already completed the intro module, then there's a CloudFormation template that lets you continue, the labs from there. If you have not, then we have a template that already has, everything that you need, or the state you would be after completing the introduction module. So all these are completely independent of each other. You can start wherever you want and learn the topics that are of interest to you. Likewise, we have a monitoring module that talks about, DocumentDB today has about 50 plus metrics to monitor, but we talk about the key metrics that we recommend as a best practice to monitor, and this lab walks you through those monitoring metrics and how to go about monitoring DocumentDB metrics in CloudWatch. We also have a template here to automate some of the dashboards in CloudWatch so that you can use this without having to reinvent the wheel. And then fresh from the press, right? So we have this security module, which was released like on Friday last week. We always, security is job zero at Amazon, and hence DocumentDB follows the same, right? So we always see customers asking us how to use Secrets Manager with DocumentDB, right? So there's a native integration built to Secret Manager, and this lab module walks through that Secrets Manager integration for you. We talk about how to set it up, how to rotate your secrets, and all that good stuff. And then DocumentDB integrates with KMS for at-rest encryption. And the default is using KMS managed keys, but here we talk about how you can bring your own key and encrypt data using KMS with your key. So this particular section talks about that. And then DocumentDB today has role-based access control at a cluster and database level, and we give you some examples and labs on how you go about setting role-based access control so that you don't give everybody master user access, for example. And at the end of each labs, there are sections to clean up so that when you run this in your AWS account, you don't have to continue incurring charges. You can clean up the resources, and it takes about a couple of dollars, to be honest, to run all these labs. So it's pretty cost efficient, and you can also clean it up. And the rough time it takes us maybe a couple hours to 2 hours, 15 minutes or so. But that's pretty much about the time requirement and the cost it takes to run these labs. So if you guys are interested in learning more about DocumentDB, I would strongly recommend that you give these lab modules a try and give us your feedback on what you see.
Yeah, can you? This is awesome, and it's great to see new releases being announced here on the Twitch show. You heard it here first, people.
That's right.
What would you say is sort of the approximate time it might take to go through each of these modules?
Yeah, so like I said, right, we've done this for customers, and of course not the security module because this is like brand new, but the other 3 modules we have completed in about 1.5 hours, all in all, and that's why I said like it will take maybe a couple hours, and for all the 4 modules, if you're interested in going through them step by step.
Cool. Cool. Yeah, so go ahead.
So Karthik, with that amount of time, given how you'd size a DocumentDB cluster for the exercises, a couple dollars of non-free tier resources?
That is correct. Yeah. So we run a very small Cloud9 environment for you to interact with DocumentDB. And then we start with a single node T3 medium instances, which is about 78 cents per hour. So, you run even the Cloud9, I believe, is a T2 micro or something like that. So monitoring, we don't do we don't exceed the free tier for monitoring. So that comes at no cost to you. And likewise, there are a couple calls to secrets manager. So it's $2 or less is what you would be paying. Again, assuming that you finish this in 2 hours and clean up the environment as provided, in each of these sections. And also, if you want to do all the labs together and clean up in one shot, we have a, for all the 4 modules we have a common cleanup section over here. So you can just get rid of all your resources and save cost.
Cool, that's awesome. Yeah, I ran through the migration module myself yesterday, and yeah, it was really helpful to go through that process and be walked through, because it's not necessarily obvious, how to go create replication sources and replication targets in DMS. So it's really great to have just a step-by-step walking you through that process.
Right. Yeah, and we cover MongoDB migration here because that's what we see, more often than not. Like a lot of our customers migrate from MongoDB primarily because the cost is high, or they want to move to a fully managed service or whatnot. So that's why we chose to use that as an example here. But there are other sources for migration as well. We do see people migrating from MySQL and other relational sources. We do have blogs on those, but again, we would love to hear from the folks here to see, if that's something that they would like to see here. So one thing we, always look for is feedback, and a lot of these modules are added based on customer feedback, security module especially, right? When we see customers asking for, hey, how to do secrets manager, how to do, bring your own keys and stuff like that. We thought it's easier to add that and give that as an a lab module with step-by-step instructions. So MongoDB right now we have online migrations, but we also, when we present and talk about various MongoDB migration methods, there are customers that do complete offline using dump and restore. There are customers that want to use a combination of it because they may have terabytes of data. So we have a combination of dump and restore and online. But if you set online, the others are pretty straightforward to do. So that's why we chose to go that route.
Awesome. One of the things I should have said at the top of the call is feel free to ask questions in the chat, and we will address them live. And we did get a question, Karthik. I wanted to pop it up on the screen and see if you could handle this one.
Oh, so how does CDC work? Is it just like MongoDB? So if it is in the context of migration, we do the way the migration would work is, you would size your oplog accordingly, and the DMS, you'll add MongoDB as your source, and the changes from MongoDB are replicated in real time by the replication instance in DB in the DMS. But if you're just asking in DocumentDB how CDC works, we do have change streams. So change streams would let you consume the real-time changes that comes into your DocumentDB, or so-called mutations, the documents that comes in, and you can consume that using change streams, and then use an event bridge lambda combination to move that data to upstream or downstream systems.
Great. Yeah, thank you. And good question, DevQW. Feel free to ask any other questions in the chat if you guys have them. We'll just be moving right on. Karthik, anything else you want to add on this workshop?
No, that's pretty much it. I don't know if you've already shared the link. Otherwise, I'll go ahead and
share.
Okay, thank you.
Yeah, I'll put it up here again. There's the link.
Awesome.
It's in the chat.
In the blog chat, I have I think I have a email mentioned there for feedback. If not, even over here, folks can chat, share the feedback on the Twitch show, and on what they would like to see, or feedback on existing content. Happy to listen to those feedback and see what we can do about improving this as we go through the journey here.
Very good.
Cool.
All right, let's move right along. Thank you, Karthik. That was great, and feel free to run that workshop. Like Karthik said, if you do run that workshop, make sure you clean up the resources when you're done, because you don't want to leave just a meter running there that just bills you forever. The workshop does actually I think at the end of each section tells you how to clean up the resources that it started, correct?
That's correct.
Yeah. All right, one of the recurring segments that we have on this show is where we take either a support ticket or some issue that happened in the field and dissect it. So we show you what happened. Usually, Usually what it has been in the past is something where the behavior was driven by something that could be fixed on the customer side. Maybe they had a bad index and they needed to make a new index or start using the index because they weren't using the hint operator, or they were leaving a cursor running forever and that was chewing up memory. Something like that could be fixed on the customer side. But this is a different kind of issue. This is what customer opened a ticket saying that they had the freeable memory graph on their CloudWatch was just sort of continuously going down over time, and eventually causing a problem, and they couldn't figure out why, because their other graphs were showing that their database just wasn't that busy. All right, they weren't sending that many commands at the database, they weren't sending that many queries at the database, and nothing that would indicate that something should be just chewing up memory all the time. So there was a little bit of confusion there. They opened a ticket. It did turn out that there was a memory leak on our side, which we addressed very quickly. And I wanted to point this out because I know sometimes people think like, well, it's probably not a problem with the service. It's always, a problem on my side, something I'm doing wrong. And, if you're not sure what's going on, please contact us because we can take a look. And every once in a while, it is something that we need to address on our side. So, this wasn't a problem that led to an outage in the customer, or didn't lead to any data corruption. There was no serious problems like that, but it was something that we did need to address on our side. And, we were happy that the customer found it and told us about it. So, it's not always you. And, we don't duck the hard questions here on this show. We always tell the truth. And anyway, so that was an interesting customer ticket that I thought was worth showing there. And that's all I want to say about that. All right, so I'm going to pass it over to Tim. Tim is one of our principal solution architects based out of the Boston area. Tim, I don't know if there's you guys getting snow up there too? Is there a blizzard going on, or is it just New York getting hammered?
We have, I think when it leaves New York, it's coming our way. My town's expecting, I think, 4 to 8 inches in the next 24-ish hours or so. But that's no big deal.
I don't know about you, but Well, see, that's the thing. I got to go out and shovel every time this happens. This is like my third time in 2 weeks, so I'm pretty sick of shoveling. But all right, enough about that. Let me turn it over to you. Tim's going to demo Robo3T with DocumentDB.
Thanks. Can you turn on my screen share?
Yes. All right, you're live.
Excellent. All right. So before we get started, to kind of tee it up a little bit and talk about why, I'm going to show you what's here. This has been blogged about, and there's some documentation specifically to this point. But if we look at the problem we're trying to solve, we have a great tool called Robo3T. It's nice for interacting with DocumentDB to be able to run queries, drill in, look at your data. But the issue becomes you're going to run Robo3T from your machine, either Linux, Windows, or Mac. You're out here, and where your DocumentDB instance is running is over here within Amazon. And DocumentDB, it's an AWS service that currently supports strictly running within the VPC, meaning it can't have a public IP address. So your DocumentDB cluster, when you spin it up, is going to have an IP address from your VPC. It's not going to be routable from the public internet. Some Amazon services actually allow public IP assignment. Like an EC2 instance, you can always create both public and private IPs on EC2s. RDS MySQL is an example of a data service that would allow you to have a public IP address. It's really not a best practice. If you think about it from a MySQL perspective, if you put a public IP address on your server, chances are the world over time is going to figure out that they can start trying to authenticate on 3306, which is the MySQL port. And as long as you have good security practices, you obfuscate the name of your accounts, you might be safe, use really long passwords. But it definitely causes wear and tear on the database, having to deny authentication attempts, which shouldn't get there in the first place. So even like at an Amazon service that would allow a public IP address, probably not a good idea. But the way you actually get from Robo3T into your DocDB is going to be through what's called a bastion server, or some people like to refer to it as a jump box. And that jump box is going to have a public IP address on it. It's going to be an EC2 instance. It can be tiny. I think the jump box I'm going to show today, I stood up with a G instance, which is Graviton 2, super inexpensive, can be very, very small, not a lot of money to run per hour. And you want to make sure that the surface area of that jump box is as small as possible. All it's there to do is to serve as an SSH endpoint. So you're going to use an SSH key, obfuscate. The account name is going to be EC2 user for Amazon Linux, for example. But that's all the machine is going to do, and it's going to make sure that there's no additional load being put on your DocDB server to be dealing with any authentication attempts that didn't come through there. So as the screen shows here, Robo3T is going to create an SSH tunnel to the jump host, and then the jump host is going to forward anyone who is able to successfully SSH into it onto the DocumentDB server and back. A couple things we're going to need to do to make this work. Number one, we're going to definitely need the private SSH key and username from our jump box. So I already have that on my machine. But the other thing we're going to need to do is to download a root certificate. And the reason for that is to do TLS encryption of the traffic to the DocumentDB server, we're going to need the root cert to be present for Robo3T. So I'll show you how to get that in a minute, and as well as how to enter that into Robo3T to make your connection. Let me grab the link. Copy link address. So it's lots of documentation online about how to grab this cert, but if you just put it into your browser, it'll download it automatically, and then you'll have it in your downloads folder. You could also do a wget if you're running this from the Mac or from Linux, from the command line, or from a PowerShell window. But you're going to want to make sure you get that root cert so you could be running TLS. And this is really going to give you 2 levels of protection. You're going to get encrypted SSH traffic between yourself and the bastion. But also having the TLS encryption on your client traffic is going to continually protect the data within as well. just a good practice to be as secure as possible. So to take a look at the setup, and this is kind of an example of what Karthik was talking about for the workshops and training. You can run really, really small, inexpensive clusters of DocumentDB when you're getting started, just learning how things work. So an example here would be I've stood up in advance. It takes a few minutes to do this. A small DocumentDB cluster with just a primary and a replica, and I'm running it fairly small. It's on it's T3 medium, which is currently the smallest possible. And what we need to get out of our cluster, having stood it up in advance, is we need to know the fully qualified domain name. And of course, I'm going to have to re-authenticate. Get me back in.
We're doing it live, folks. Doing it live.
I've never been able to find out what the timeout is on that. I don't know if you guys know how long it takes for us to get timed out. Does anyone have any Jeopardy music to play in the background?
That's funny.
Come on, Isengard.
One thing I'll add to your point about TLS and an encrypted connection with DocumentDB, encryption at rest and encryption in transit is enabled by default. So whenever you spin up a brand new DocumentDB cluster, those things are already enabled for you. So we definitely try to put you in the best place from a security footprint whenever you launch a DocumentDB cluster. Of course, you can change those and turn those off. Don't recommend it, but you do have that granularity to make those changes.
Just about there.
While we're doing this, let me pop to one of the viewer questions. We had a follow-up question on the change data capture. Let's see, where was it? They were asking if it works like a Lambda execution event. The answer is no, it doesn't. I mean, you know, every database product is a little different. Like in DynamoDB, you can have a change data capture system that automatically triggers a Lambda function. We don't have integration with Lambda on DocumentDB side yet. You know, maybe it'll come one day on the roadmap. We're not sure, but for now, what happens is you need to write some code that processes the queue of events that are coming out of the change stream. And you can actually, and what a lot of people do is they'll actually have a Lambda function triggered by CloudWatch that then goes and processes, you know, say once a minute, everything that's in the change stream. So that's one option if you want to process it from a Lambda function. Some people just have a long-running process, say in Fargate, or you know, some Dockerized process running in Fargate or something like that. Kubernetes that pulls the change stream, wakes up every few seconds and pulls the change stream to see if there's anything to do. So there's a few options for processing the CDC events there.
Just about there. I got re-authenticated. I'm trying to bring up the DocumentDB console now.
And I will add, we do actually have a AWS Twitch video where they announce change streams for DocumentDB, and I believe in that video they actually do a walkthrough of how you would do something like what Chad is talking about. Post that Twitch link there.
Yeah, I also shared a blog there, so that uses change streams to move data to Elasticsearch from DocumentDB to perform full text search. So it's a classic use case. So you can go through the blog to see how to use change streams in DocumentDB, and that uses even Bridge and Lambda, so you can get a feel for how to use Lambda function. But like Chad said, there's no direct trigger yet. So
it is a classic use case. We actually demoed this exact use case on episode 1 of this Twitch show. So if you go to our YouTube channel and look up episode 1, you can see where we walk through actually what the code looks like for processing the change stream in Python, you know, and how to actually run that and integrate it with Elasticsearch. All right, I think Tim's ready to go here. Let's give it back to Tim.
Yeah, I just brought up my task manager in my second window, and for a little while there, I was system interrupts 100% CPU. So it is definitely bogging at the moment. This is just my laptop, nothing to do with our services. All right.
No, yeah.
So the first thing we need to get after we have our
the streaming software chews up a lot of CPU, so that's why the browser runs slow.
Got it. Okay, so the first thing we're going to need to do for our DocDB cluster to be able to connect to it is right here. That's the fully qualified domain name of it. And again, these are only routable through private IPs addresses. So if you do an NS lookup or try to ping that, it'll be you won't even be able to do a lookup. But that's what we're going to put into our tool when we tunnel into the server itself. So first thing you need is the fully qualified domain name of the server. The next thing we're going to need is for our bastion. We're going to need the IP address, and if my browser continues to crawl, I will potentially skip that. I know what my IP is that I'm going to, but try to bring it up by bringing up the EC2 console. And it looks like Chrome is still struggling there, so okay. So we're going to bring up the EC2 console.
Speaking of Jeopardy, I've been enjoying having Ken Jennings as the host. I mean, he's no Alex Trebek, but he's very good in that role.
You're a fan?
I'm a fan.
There's been some interesting. I'm curious to see who the other fill-ins are going to be. But it does seem like lately people are willing to go all in and do seriously larger bets on the.
Well, Jeopardy James changed the game for sure.
I want Will Ferrell as the host.
Yeah.
I want
oh my God, that would be amazing. That would be amazing.
I was hoping for Steve Harvey personally.
Oh God.
Oh no, absolutely not.
Rob Gronkowski.
Gronk. Yeah. Oh my gosh.
I'm sure.
Yeah. Gronk would be funny.
Gronk. He tried everything else in his.
He was on Shark Tank. He was on Shark Tank once.
Yeah, he's got the money to invest. That'd be interesting to see what he would go in for.
Oh, he wasn't on as an investor.
So Chad,
his brother actually was a. Yeah, I would just you know the IP. I would just move on.
Okay, so step 2 is to get the IP address of your Ben, and then step 3, and there will be a link to the blog. The last thing you have to do is you have to add a rule, an inbound rule to your Bastion server to allow connectivity on SSH from the IP address of your home IP address, so you can get in there. And I already know that, so I'll basically walk through the setup now on the Robo3T side. All right, so a couple things we have to do here. We're going to create a new connection in Robo3T. A little create button right there. We're doing a direct connection. Going to give it a name. We'll call it Twitch S2. And the address here is going to be the fully qualified domain name of the DocumentDB server itself, which we would get from the DocumentDB console. Under authentication, we do absolutely want to be performing authentication. We leave the database alone. When you create your DocumentDB cluster, you're going to actually give it the name of the admin user that you create, and as well as give them a password. So I'll type that in here. And we're going to be tunneling, so we're going to use an SSH tunnel. The address we're going to fill in is the address of our bastion. We're using AWS Amazon Linux 2, so EC2 user by default is the name of the user that gets created in your instance. We're going to use a private key, which you should have downloaded. You're going to be using that when you create your EC2 servers. So that'll be under downloads here. There's my PEM. Under TLS, this is to make sure we're doing encrypted traffic between our server and the client. We're going to use a CA certificate, do a lookup on it. That too, I downloaded earlier in the browser, so that's right there, the PEM file. You do want to check advanced options, and here we need to be allowing invalid host names since we're tunneling. And then I don't think there's anything under the advanced tab, and we'll do a test here. Of course, I get one more failure. Ssh Tunnel. Key, my passphrase. So Chad, pretty much everything that could go wrong on this one has so far, which is, I guess, to be expected from my first time on Twitch.
Well, that's the law of live demos.
And you saw there, I changed nothing. I repeated my test and it worked. So we'll just chalk that one up to experience. So now we've got a connection that we can. Now we've got a connection we can tunnel directly in. One thing we'll do, I preloaded. Yeah, it worked and then it didn't. I think it's all due to my machine really not working well with the stream. There I am, I'm in. So what I did in this collection, there's a lot of amazing, interesting data sets that that are open source, free to the public. If you get them CSV or JSON, they're really, really easy. I'll probably in a future Twitch talk about some fun data sets to play with, how to easily get them loaded into DocumentDB and query them. But what I want to take a peek at is I grabbed a data set called Meteors, and this is as you might expect, it's since they started recording the information through 2013, every meteor that's fallen to Earth and been tracked has been given a name. And it's kind of interesting when you look at the old data, the names were almost like hurricanes. There were lots of interesting, unique names. And then whoever names them got to a point where there's just too much going on and you have to just have kind of generic names with numbers in them, almost like creating a Gmail account. But it's pretty cool. It has the mass in grams. Fall, I think, is fell or identified, or something like it. I haven't quite figured that out yet in there. They tell you the year. It's not the actual date that the meteor hit the Earth, and then you get a lat and long and a geo. So it's got some pretty cool data in here. But what I liked to do with that data, I ran an aggregation query over it to see. My curiosity was, are more or less meteors hitting the Earth? So I put together an aggregation query, and the fun thing you can do with that is, how many meteors have hit the Earth by year. So here's 2013, 2012, 2011, 2010. So in 2012 there were 234. 2011 there were 713. So it's kind of interesting to see. 2006 seemed to be a banner year for meteors at 2,456. And then the last one that's kind of interesting, I don't know if they're predicting something in the future, but there is a row in the data set that in the year 2101, it's predicting a hit. So I would check your lat and long and maybe move if it seems to be too close to where you're at. So there you have it. Hopefully someone, Chad or Karthik, if you can put the link to the blog in the chat window. And we've got really good documentation on Robo3T, Robo Studio, connecting from the CLI tools as well, for being able to get through a Bastion server to your DocumentDB server from your home office, or even anything that's not within AWS directly. You're going to be tunneling.
Awesome. This is great. And I personally have seen more and more customers actually pulling up Robo3T when I'm talking with them and showing me what their data looks like and all that, instead of using the CLI. So, I think this is going to be a great thing that more and more people are doing over time.
It's very helpful for writing aggregation queries. The CLI is nice for quick little finds and find ones, but if you're going to be iterating on something, either using a Jupyter Notebook or Cloud9 or a tool like this for the interactive query edits that you're going to be making to do more complex things than just looking up a document or two.
Absolutely. Now here's the link that you were talking about with the blog post about Robo3T. Actually, it's just a docs page. It's not a blog post, I guess. So this is part of the official docs, how to set up Robo3T. Very good. Thanks. We did get a question. We did get a question that came in asking what the AWS naming process was like. And like I said, we don't duck the hard questions here. So I wasn't sure of the answer because I'm not a product manager. I've never gone through that process. In the background here, while Tim was talking, I went and asked a product manager, and here's what he said. He said what happens is that someone on the product management team or marketing writes a narrative that considers multiple different options, from descriptive names like DocumentDB is just a descriptive names, right? It's a database that stores documents. There might be a suggestive name, like a service like TimeStream is kind of suggestive of what the service actually does. And then there's just some services have purely abstract names that don't tell you what they are, but things like Neptune and Aurora are purely abstract names. So someone will write something that considers different options. Of course, it has to go through legal review and make sure it's not infringing on anybody else's trademark, or there's some other product called that from another company, that type of thing. And then it goes through review, and it goes all the way up for approval through the CEO, Andy Jassy, formerly CEO of AWS. Of course, he got a promotion recently, and he's CEO of all of Amazon.com now. And so those decisions are actually made and approved at the end, at the highest level. All right. So good question. Okay, thanks, Tim, for that. We're going to move on now to the next demo, which is Cody Allen's going to be talking to us about how to use Cloud9 with DocumentDB. So kind of similar in the sense that it's a nice GUI interface for working with DocumentDB. And he's going to show us some indexing tips and tricks as well while he does that. So thanks, Cody, for joining us today.
Yeah, great. I'm glad to be here. So like we talked about earlier, DocumentDB lets you use the same MongoDB 3.6 and 4.0 application codes, drivers, and tools to really run, manage, and scale your workload without that managing that underlying infrastructure, right? And when you migrate an existing workload or even create a new one on DocumentDB, it's really important to know what indexes you can use and how you can use them and what the best practices are around that. Obviously, indexing isn't unique to DocumentDB. Nearly all relational and non-relational databases use them, but essentially they're there to help your queries be more efficient. So for today's demo, I'm surprised this theme never got brought up, Chad, but I am going to be using the sweep the leg DocumentDB cluster today. And I'm also going to be using Cloud9 to interact with my cluster. So just as a brief introduction to Cloud9, if you've never used it before, it's essentially just a cloud-based IDE. And from within it, you can write your code, run your code, and debug your code all through a browser window. You get a code editor with it, you get a debugger, you have a terminal built in, and it comes pre-packaged with essential tools for languages like JavaScript and PHP and Python. I do a ton of things in Python. It comes pre-packaged with a lot of tools. You go to our developer guide, you'll actually see the full list of languages we support, and we're constantly growing that based on customers' feedback. One of the nice things about it is since it's cloud-based, that means that I can work on my projects from anywhere. So it could be my work laptop, my developer machine, my home machine. As long as I have an internet connection, I can get to that environment. The other thing I like about that is if I get a new work machine, for example, I don't have to go reset up all my packages and my dependencies and my symlinks and make sure my versions are all correct. It's here within my IDE, within my Cloud9 environment, so it stays there. I have to ask people smarter than I am for help a lot more than I'd like to admit. And the other cool thing is I can actually share my development environment with other people on my team, like Tim and Karthik. And that really allows us to do those pair programming exercises. And also I can track their inputs in real time. So it's really helpful there. Under the covers, it's essentially just an EC2 instance with an EBS volume attached. So you're only paying for the compute and storage resources used to run and store your code. We actually have a very good blog post by one of your regular guests, Joe, that talks about how you can set up a Cloud9 environment manually. And we can share this link out, but Karthik was talking about our new workshop that has some CloudFormation scripts that do this for you. But if you want to walk through those steps of setting up manually, check out Joe's blog post, and it goes through setting up the Cloud9 environment, even setting up a DocumentDB cluster, as well as the security groups and the rules that you would set up for it. But really, really good information there. But let's jump right into it. So this is my DocumentDB dojo within AWS Cloud9. So what I'm going to do is let me get logged into my DocumentDB cluster here. And you can see we're hitting my sweep the leg cluster. And just to kind of give an overview of what I'm working with, I have this database that's called Business, and I have several collections within it. The one that we're going to be focusing on today is this tweets collection. And before we start talking about indexing too much, let's take a look at what this collection looks like. So I'm going to be using the stats operator a lot today. And the stats operator essentially just gives me information about the size of my collection, how many documents I have, and index information. And you can see here that I'm passing along some parameters to it. And these are just called scale parameters. Whenever you run a stats, it's always going to return the values in bytes. Well, those are hard to read if your collection's pretty big. So I'm just converting it from bytes to kilobytes and then to megabytes. And here I can see I have about 800,000 documents. My total size is about 2.8 gigabytes. Now, the one exception that we have to the scale parameter that we pass in is average object size. My average object size is not 3.7 gigabytes. That'd be insane. This is still bytes. So my average object size, my average size of my document is roughly 3.7 kilobytes. And then the other thing that we're going to look at a lot today is the number of indexes. So you can see right now, I just have a single index on that. So let's take a look at what a document looks like in this. So I'm just going to do a find one. And we have a ton of data here. I'm just going to scroll up through it. We have a lot of key value pairs. We have a lot of nested subdocuments. The thing I'm going to look at for this first discussion are these two fields, my first name and last name. So let's do a simple query where I'm just filtering on last name. So what I'm going to do is I'm just use a find operator, last name Hernandez. I'm going to add in this explain operator, and explain is going to provide information on the query plan that I'm using. And I am going to pass along this execution stats parameter. So what that's going to tell me is it includes the completed query information after I've executed the query. If I didn't include that, it's just going to say, well, DocumentDB is planning on doing this, but we didn't actually run it. By adding that execution stats, it's actually going to run that and return the actual information it's used. So let's see what this looks like. All right, there we go. So what we're going to focus on here is this execution stats. And you can see that in order to fill this query, it had to do a collection scan, but it did return me about 5,000 documents, and it took about 1,200 milliseconds, so 1.2 seconds to run. And what this means is that DocumentDB, by doing a collection scan, had to go to every single document in my collection to find this information. Think of this like a phone book. If I went to look up the last name Hernandez in a phone book and it was not ordered in any way, shape, or form, we just threw somebody on there as they moved to our town, this is roughly the same thing I would have to do. I'd have to go through every single page of that phone book to find it. And so DocumentDB is doing the same thing. So using that phone book analogy, what we can do is we can create an index on that last name so that now our phone book's in order. And what we're going to do is we're going to use our create index operator. And I'm saying, create an index of my last name, and I can do this in ascending order or descending order. Now, order typically doesn't matter for single field indexes, but if you're going to be doing sorts or range queries on compound indexes, and we'll talk about that in a second, you really want to make sure that that direction is correct. The next thing I'm going to pass in, and a lot of people forget about this, but this is that name parameter. I can name my indexes. If I don't, it'll just concatenate the names of the fields together with the order. So this one would be like last name _1. I want mine to be a little bit more verbose so I can track them easier. So let's run this real quick and create that index on that last name. And then we'll run our same query again to see how much we improved. So here we go, our last name Hernandez, immediately better results. We can see instead of doing that index scan or that collection scan, it's doing my index scan. It's returning the amount of documents I'm expecting, and it's taking only 5 milliseconds this time. So a whole lot better. I do want to segue a little bit on this and talk about another best practice that is directly related to index, since we have a very simple index here. So in our developer guide, we recommend choosing an instance type with enough RAM so that your working set fits in memory. And that working set is your data size and your index size. So when we looked at our stats earlier, we are able to see our index size. So when you're trying to figure out what that working set size is, this is where you're going to look to find out what that index size is. So right now, our last name ascending one that we just created is 25 megs. And we'll return to this here in a little bit to talk about how else you can use that to help determine your working set size. So let's move on and talk about compound indexes. And compound indexes are just when you put multiple fields together within your index. And this is really helpful when you're doing any kind of sorting when you're finding one field and you're sorting in another one. So here we're going to do same thing, find the last name Hernandez, but we're going to sort on that first name. All right, perfect. We were able to do that index scan and utilize that index we just created. But if we scroll up here, we can find out that it had to do a sort. DocumentDB retrieved all my documents for me, got my 5,000 documents, but now it had to sort all 5,000 of those documents to return them back to me to fill my query. To help it out, what I can do is I can create a compound index on both last name and first name. And I'm going to do both of these in ascending order. It's going to take us a couple seconds to get that index ready. And as soon as that's ready, we'll rerun our last query and see if we can perform on that or improve on that performance at all.
And you're creating those in ascending order because that matches the way that you're going to run the query. Is that right? That's
correct. Yeah. And this is why the order that you select is very important when you start doing sorts and aggregations. For this, it doesn't really matter because it's going to find it going both ways. But as you start doing more complex sorts and aggregation, you really want to focus on what that order is. And here we go. We can see that now, since we have the index including first name, it doesn't have to do our sort anymore because it's already sorted. We've already sorted our first name in ascending order. So all it had to do was that index scan to return back to us.
Hey, Cody?
Yes, sir.
That also, by creating that second index now, that'll also serve the purpose of the first query, right? So it's redundant having that first query, that first index?
Yeah, absolutely. Good point. And we'll kind of get to that here in just a second. We'll see another example of that. But yeah, by having this index that covers both last name and first name, that means it's still going to cover indexes that are just looking for last name. So good call out on that, Tim. So let's look at a multi-key index. Well, what a multi-key index is essentially just an index that you're going to use on an array value. And what I'm going to show you here is I have a keywords array on all my documents, and it just has random values. I'm actually using the Faker Python package. I know Tim mentioned that there's a lot of publicly available collections that you can download and do a Mongo restore on your DocumentDB cluster. The Faker Python package is another great way to just randomly generate data. But here I have all these different values, and let's say that I want to find a single value within those keywords array. So I'm going to look for a reason keyword. And just as we expect, we have a collection scan. It returns my documents, but it takes 1.5 seconds. So it's taken quite a while to get all that information back. Let me create this this index on keywords. And essentially what it's doing, whenever you index an array, it's going to create an index entry for each element of that array. If my array had 50 elements, that means that I would have 50 index entries for every single document in my collection. And I will touch on what you want to consider around that whenever you're creating indexes as far as the size and the performance. All right, now that I have that there, let's rerun. Extremely efficient. Our index scan, instead of taking 1.5 seconds, is now taking 2 milliseconds. Now what I'm going to do, and hopefully DocumentDB will play along with me, is I'm actually going to drop that index because I want to show a compound multi-key index. The first thing I'll show you is not only do I have a keywords array, but I also have this phone array on each of my document. Well, what happens if I try to create an index on both of those arrays together, both my keywords and my phone? I can't. So a compound multi-key index can only have a single array field. And that's because if it allowed me to use 2 arrays, I would have an exponential number of index entries, because remember, we're indexing each entry of an array to create an index value for that. So if I had 5 arrays in one, or 5 elements in one array and 50 elements in another array, that means that for a single document, I'd have 250 elements of that index for that single document. So that's why we don't allow that. What I'm going to do now is I'm going to change it up a little bit. I'm going to try to find a user by their age and then an element within that keywords array. And again, it takes a long time, about 1.2 seconds to do that. What I'm going to do now is I'm going to create an index on my age and keywords. And just like before, it's going to take a little bit of time because we're creating an element for every single item in that array. And as soon as that's done, we'll rerun that last query and see how much better we got. So we're at 1.2 seconds for that collection scan of the first one.
Cody, we did get a question.
Mm-hmm. Let me bring up my screen here.
The question is, so if the name index is 25 megabytes, the naive 50 ELT array index is 50 times 25 megabytes?
Maybe you can explain that question a little bit more.
Yeah,
I'm
maybe.
Not sure I follow.
I'm not sure I understand the question either. If you have some clarification, by the way, we have about 2 minutes left, Cody.
Okay, so we'll just kind of end on this example, but here we can see my index scan was a whole lot quicker, and I wanted to again see if DocumentDB will play along with me. I'm going to recreate my keywords index that I created on the keywords array, and then I want to rerun this document to see which index DocumentDB is going to choose. Because remember, I created an index on age and keyword, so it matches my query exactly. But let's create an index just on keywords alone and rerun that query and see which index it chooses. All right, there we go. Perfect. So this time, DocumentDB chose a different index. It chose that keyword index. And this is an important thing to point out. This is why it's so important to use this explain operator in the execution stats to look at each one of your queries. Because if you know that you have a better query to run or you're not sure what's going on, this is going to help you determine that. And the cool thing too is we actually allow you to use the hint operator in DocumentDB, so that in this case, I know I have a better index that fulfills this query. I can pass along a hint and say, hey, I have this index that already exists on age and keywords. Go use that one. Don't use this one that you think is best. Use the one that I'm going to tell you. And when I do that, you can see we're back to using the better index, getting better performance on that. So I know we're running out of time, so I'll just wrap it up on there. Shameless plug, we do have a blog post coming out that's going to talk about all these different indexes and more, best practices, and give you some queries you can run on your MongoDB cluster and DocumentDB cluster. So look for that, and hopefully we'll have a link for you shortly that goes through all that.
When do you think that blog post will be live? Do we have a rough date?
Not yet. Soon, very, very soon. I'm hoping by the end of February, but we'll see how the schedule goes with it.
Okay, great. Yeah, if it comes out, we can announce it at the next Twitch show. All right, great. Thank you. We're out of time. Thanks, Cody. Thanks, Tim, for coming on to demo these great ways of connecting to DocumentDB with a nice GUI and some nice in-depth look at multi-key compound indexes and stuff like that. That was really nice. I'm your host, Chad Tyndall, joined by my guest host, Karthik. And I want to thank everybody for joining today. Our next episode is going to be 1 month, actually, March 18th next month. Same time, same channel here, 8 a.m. Pacific, 11 a.m. Eastern. And we'll announce on LinkedIn and also on Twitter what the topics will be a few days before the event. Hope to see you guys there. Feel free to follow us on Twitter. Those are our Twitter handles there, and you'll see announcements coming from us. Thanks, everybody, for joining, and we'll talk to you in a month. Stay safe out there.
Stay safe. Bye-bye.
So long.